Okay, so what I did was first I vibe coded an app. It's an MP3 player, and the main reason I wanted it is because I like browsing my music just from the folder structure. So I'll show that real quick. So here we go. We're going to start up the app. And it says, please choose a root folder. That's the text we're going to change. Go to settings, select music, select MP3s, use this folder. And now when we go back, we can see my made up genres, and then we can drill in. We'll see bands and stuff like that. And of course, drill in, see albums or just MP3s, whatever. And this is how I've always liked to browse my music. So that was just the first step. I wanted to build a GitHub Actions workflow from beginning to end, fully automated. And I just wanted to define the user story and basically have the code built, tested, automation built and executed. And so that's what I did. Vibe coding the app took a couple hours, probably could have taken even less because it's extremely simple. And this whole flow took, I don't know, 4 days, maybe something like that. I knew nothing about GitHub Actions before this. I've never made any integrations, never made any significant integrations with Jira, never made any integrations to Slack, and I had never run on AWS, never run automation on AWS in the past. So what is going to happen is I'm going to set this to ready for AI, and it is going to send a message to this JW Player repository. It is going to look at the story, look at the code base, update the code base based on the story, open a pull request, then a second AI is going to, first we're going to lint it, and then a second AI is going to review it, fix it if necessary, and that would be, there'd be relenting. After that, and unit tests run. Then after it merges, if the reviewer bot thinks that it's okay, it will merge it, send a message to this other repository, JW Player Automation, which will first create manual test cases, which are just stored in a text file in the repository because I didn't want to mess with, basically I couldn't find a half-decent free test case management tool. In this case, since we're just modifying something, I'm just going to change the text a little bit. It's going to reuse an existing test case and modify it. Then it's going to build an automated test script for it, or in this case, again, just modify the existing automated test script. Then it is going to execute the test script on a real device. I think they're real devices, and maybe they're virtual devices, maybe they're emulators, on AWS. And once that's complete, it will push. Before that's complete, obviously, it will create the automated script, push it to this repository, and then run it on AWS. And all along, it will be changing the story status in Jira, and it will be posting to Slack. So I made some little lines here just as a delimiter so that we can easily watch it, and we'll also see how much it costs, because of course all the LLM usage is going to cost us something, and this will cost us, it's 17 cents per device minute, so this runs for a minute and a half, so it'll cost us about $0.25 to run these two automated test scripts. Obviously we're not going to run the full regression each time. What it does do is it runs any new or updated test automation scripts, and it will run one critical path test automation script, which basically goes in, uses predefined data that we upload, and plays a song for like 5 seconds and just makes sure that the counter is counting up. So make sure that the playing the MP3, which is pretty critical, actually works, at least as far as it can tell. And then we'll have Claude over here watching it. So I'm going to say this, and then we'll look at some documentation I had Claude make for me. I'm about to set this story ready for AI. Watch it, and it'll say, okay, it'll do it. And I'm going to go back over here, set it to ready for AI. Go into these workflows. Okay, kicked off. Oh, and we'll also look at the source over here. So check out, it should have already, there it goes, set to AI coding. It does that when it does the first checkout. Oh, there it is. Let's see if it says anything over here. I guess not yet. I think it just does results over here. I could have obviously had it say AI starting. But the idea being with the story that if it fails, I mean, it will set it to AI coding failed or AI testing failed. Sets it to AI coding just so that we know something's happening. Maybe that's something that could be done. That would be nice. So this does take several minutes. And in the meantime, I will talk about some lessons learned. I asked Claude to keep track of lessons along the way, and when I found some things, I said, hey, make a note of that and write it to a markdown file. So it did that. Anyway, it was just a summary markdown file. That thing blew up, but I just kind of went through it and found some of the lessons learned. And some that Claude came up with were don't trust, one example is, don't trust a reading of the evidence without checking it against real code and behavior. So a lot of times it would just read a log and then start going back to the code. And I would say, hey, give me a minute. I had it on auto mode down here, and it would just start going, and I would have to tell it, stop, let me look at this before you go down this rabbit hole, especially running on AWS devices, because this integration, unsurprisingly, was the most difficult part. All the other integrations are very straightforward. But getting the test data loaded, and at first, Claude had this idea of setting a backdoor to set the root directory so that we didn't have to manually go to the settings screen and go to the Android file browser because, of course, that's going to be different on Android devices. So AI Claude said, hey, let's create a backdoor, and that just never worked, basically. I finally said, this isn't working, let's just simplify. We will just go to the settings screen. It's only 4 clicks. It takes 7 to 10 seconds. So it was really going down a rabbit hole, and it seems to me that when you let it go in auto mode, it will just keep pounding on one solution, and it was not very good at lateral thinking. I had to stop it and say, let's try something different, and let's simplify what's going on. Finally, I said, please, let's just stop running this on AWS devices. Let's run it on an emulator locally and take some of those variables out of the equation. And then that was when it couldn't find an element. And in the DOM, if you will, in the page source that Android is giving, the UI Automator 2 is showing, it would, the tag was on one view and the text was on another view or something like that. But it would get attached to a solution and really go down the rabbit hole. Another thing that I just talked about several things, including simplifying, decomposing a problem, trying to think laterally when one solution isn't working. Right. Something it learned was that local reproduction beats iterating on real hardware, which is quite obvious. I've heard people say that Claude writes very defensive code, and okay, let's at what's going on here. So, okay, did not have to call that, no changes made. Because it's very simple at coding. Let's see what it said over here. Okay, story implementation, pull request, spat out the Jira, so we have handy links to that. So let's back out of here. All of our actions. Okay, story writer for AI. Let's see if that pull request. Okay, it's open, so it's probably doing the unit testing. Maybe, I think this is, I guess it would have already run the unit test. Now it's doing a code review, and it will merge that pull request in a minute. People have said that AI writes very defensive code, and it certainly I've seen that, but when it was trying to fix solutions, it was kind of going to the first, kind of naively, seeing something and thinking, okay, let me try to fix it really quickly. It was very optimistic in terms of, I have a proposed solution, I'm going to implement it. Instead of looking a little deeper, I've been using Sonnet. Maybe if I was using Opus, it would have done a little bit more thinking before rushing to implement a solution. But in terms of not being defensive, it got caught several times for like colon characters in YAML files and things like that. Right. It had some solutions like in some GitHub Actions, it was putting information into buckets, for example, code commits in order to communicate between one GitHub action and another. And then the next, the following GitHub action would grep for that information, like a Jira ticket issue. It's called now they call it work item ID. Put that into a code review, code commit message, and then grep for it later, which does work, but it can be kind of brittle. And we went with a better solution after that. Instead of asking the AI kindly to put it in the code commit for us, we actually appended it and did a commit modification, commit message modification step, just to make absolutely certain it was in there. Still grep for it. Still seems brittle, but in a real world production system, I would have had to come up with a better solution. The automation code, I would say it was not very human. Let's see if this is merged yet. Yeah, still doing the code review. I would say the automation was not very human. For example, when you're running on, especially when you're automating native apps on iOS and Android, you have to be pretty generous with the phone. You have to be pretty forgiving in terms of a lot of phones and a lot of device clouds are slow. And so, for example, terminating and relaunching an app, you're just going to have to wait a second or two if you want it to be consistent. You can try waiting 1 second after terminate, 1 second after launch, and start automating, start looking for stuff. And of course, you're going to be looking for elements before you take any actions. So you shouldn't have to wait. You shouldn't have to do hard waits. But the reality is that just takes a little time, and it's going to be a little more consistent if you take a little bit of a human approach. If you just have 2 lines of code, driver.terminate, driver.launch, or something like that, it's entirely possible that the terminate is going to still be kind of, the app's still going to be kind of terminating when that app launch runs, and it's just not going to work 100 times out of 100. And 97 times out of 100 isn't enough. So I would definitely put just a 2-second wait in there. And I know that that's not fun to hear, but it's just going to make it more consistent. And 2 seconds when you're, just a really simple test is taking a minute and a half. 2 seconds is not that much versus, an engineer, a human engineer having to look at that even once a week. That's at least 10 minutes of work, and 2 seconds and 10 minutes divided by 2 seconds is clearly it's going to be worth it, basically. Well, this code review is taking longer than I would have expected. Yeah, some of the test case steps, some of the automated steps were also a little bit brittle. Again, not what I would call realistic, based on apps running on device farms, which are often a little flaky or slow. Right, I talked about how it would see some error and go and try to fix it instead of discussing it with me. And maybe that's just because I need to train it a little better. Okay. Finally got a success verdict on that build. Okay, so it also... Oh, we're not there yet. Okay, so this... Okay. Merged. Close. Let's see if it's... Okay, move to AI testing. Over here. So it sent the dispatch to the automation repo. Okay, now that's creating test cases, which is really just going to update a text file. Oh, and we can go over here. Woohoo! JW player. So this was from 12 a.m. And there you go. Got some new stuff just a minute ago. It's pretty cool. Now we'll go over to JW Player Automation. See if it's done anything yet. 12:29. Okay, not there yet. I didn't mess with pull requests and code reviews on this, since it's just prove that kind of point over here. It's just going to push. But it does do, this is Python automation, so it does type checking, and there are some unit tests that it runs on the test automation, and then it will run the actual automation on AWS. Still testing. Obviously, I guess it's going to be several minutes. Existing text fixed. That's cool. There's the test. Empty library, blah, blah, blah. There's a test case ID that is not the work item ID from Jira. Those are separate. Oops, what did it say? Yeah, unit test and type checking passed. Cool. Let's see. Okay, so it test, right? This is how it communicates when it kicks off the test automation on AWS. It has to know what the last generated set of tests are, so that's in here. Change the text and change the test case name. That's interesting. and change. This is the unit test that it changed. Okay, now we'll go over here. Last one, okay, pending. We'll go in here and watch that run in a second. Type check. Should still be testing. I guess we just gotta wait. So all the calls to the Cloud API are complete. We'll see how much it cost. $10.09. $10.67. Not bad. I mean, that being the case, it was pretty simple stuff. Like extremely simple. Didn't have to think too hard. I'm using Sonnet for that also. Go in here and look at the logs. It's kind of annoying. Okay, well, there's a few annoying things about AWS. The way they provision devices to be run on, in the past, what I've seen is you have a suite of tests and you have a suite, or you have, I'll say, a group of devices, and your suite of tests run randomly on those devices, which is good because then every time you run it, it's a little different. And eventually, all of your tests run on all your devices. The way Amazon does it is you say, give me 3 devices, for example, and then you have a suite of 10 test cases, 10 test scripts, and all 10 of those test scripts will run on all 3 of those devices. So your parallelization is not increasing the speed, it's just getting more coverage. So you have to yourself break your test scripts up into multiple suites, and then you can choose which devices they run on and stuff like that. But like, personally, I think that's a terrible way of doing it, and as far as AI, Claude and I can tell, that's how you have to do it. That pretty much blows my mind because that makes scaling a lot more manual of a process. And I've been doing this a while, and I have not seen many times where the hardware, where bugs are introduced by different brands, Samsung or Pixel or Huawei or OnePlus, or screen sizes, different versions of Android operating system. Back in the day, they were pretty different. 10 years ago, you'd want to test a couple versions back, but everything's converging. Most phones are pretty much the same. Samsung always has a lot of bloatware, and a lot of people use Samsung, so it's definitely good to test on them. But it's just a weird way for them to set it up, and I really don't care for it. Anyway, that was a real surprise. I had never used AWS before, AWS devices. So we'll watch this video. We kind of launched it and killed it a couple of times. That fixed the problem. If it was a production system, I would figure out I would spend more time figuring out what the problem is. So it just read that. Choose a root folder. And now, okay, so now it's going to go in here, select the folder, and okay, Device Farm extra data. It's going to drill into genre C, artist A. Going to play the song, make sure that the little counter is increasing. So should be done. Okay, cool. Switch that to done. And over here, set up test pass, and that's pretty much it. See a couple of things updated 6 minutes ago. Let's generate test. Where are they? Test and unit test. this just really pretty much blew my mind. How how easy it was to do this with Claude. I found Claude Code to give me lots better answers, much better answers than like ChatGPT in the web and stuff like that. And maybe it's because most of my questions were about code, but even when I asked it about, as I was using it, of course, I was asking about lots of desktop apps and things like Node and Homebrew and stuff like that, and it was right a higher percentage of the time than asking web interfaces, the chatbots, and I don't know why that is, but that seemed pretty consistent. Um, it all worked. Blah blah blah. Watching it, Claude watched it for me, and the last thing was I asked it to make some system diagrams with transitions from low level to a high level view. So this is okay. There we go. These are just the Jira status states, which I didn't ask it for, but it made it anyway. Well, dispatch, receive, PR, the triggers, the different states, and this looks better. This is just this web interface on Claude.ai. It gave me some SVGs, and they look better than this. The high-level flow, stories written, dispatch, implementation, linting, code review. If it fails, it needs a human. Blocked, whatever. Approved and merge, automation, test case generation, script generation, type checking, unit test, real devices, failed, done, Slack post a message. And then here's the full pipeline. For some reason, went from top right to bottom left, which is funny. This is not very pretty, but it sort of makes sense for an AI generated document. And this is first pass. I just said create these docs. It did this. I said fine. Yeah, this only took working most of a day for 4 days. Most difficult part was the last mile, I would call it, getting it to run on real devices. But in general, I'm pretty much blown away. I'm sure a real DevOps person would look at some of these GitHub Actions and shake their head, but it got me there. Pretty simple stuff, probably not super robust, probably kind of brittle, but I mean, still, it'll be better in 6 months from now. Mind blowing and also quite scary. And that's my takeaway.